Hi students, this is Mr. Yao. In this lesson, we are going to learn how to solve system equations with quadratics. So we can solve system equations typically in two different ways, graphically or algebraically. To solve it algebraically, you have learned before that we're using substitution or elimination, and you're finding solutions that actually work for both equations. As for graphically, well, that means you need to graph both functions and then you're finding the point where they actually intersect. In this lesson, we're going to focus on solving algebraically. First, before we start solving, we need to understand how to decide if a point is a solution to the system equation or not. And that is by plugging the point into both equations. And it has to work for both equations. So, example 1, you're given a point. In order to decide if it's a solution or not, you need to plug in x and plug in the y. So that's the first equation. Left side is -4, right side is 1 squared minus 10 times 1 plus 5. And you're trying to decide if they actually equal or not. The left side stays -4, the right side after calculation, it's also -4. And that means that they're the same, so the first equation works. You also need to check for the second one. Plug in 1 for x, plug -4 for y. So we got -4 equals -4 times 1 squared plus 40 times 1 minus 32. Still, we're trying to decide if they equal. Left side is -4. Right side after calculation is actually going to be a +4. So they're not the same, which means it doesn't actually work for both equations. So not a solution. You can pause here and try example 2. Now let's have a look. So example 2, second equation is going to be very easy to plug in. So we're going to get 3 minus 6 plus 3 to see if that equals to 0, and it does. So that one works. Now we're going to plug into the first one. For all the x, you're going to replace them with 3. For all the y, you're going to replace them with -6. So we're going to get -5 times 3 squared plus 2 times -6 squared plus 10 times 3 minus 2 times -6 minus 69. We're trying to see if that equals to 0 or not. After calculation, the left side is a 0, so it actually does equal, and it actually works for both equations. So yes, it is a solution. There you go. And that's how we decide if a point works for a system equation or not. Now let's see, we're going to start solving system equations with quadratics. We can't exactly use elimination because one equation is going to have x squared, the other doesn't. So we can't eliminate anything. That's why we have to use substitution. Here are the steps. Step 1. Choose the linear equation and solve for y or x. As for your solving for y or x, that depends. That actually depends on the other equation. So, for example, this question on the right side. If you look at the equation that has quadratic, well, you have an x squared and an x. So if you actually choose to substitute x, you're going to have to do it for both. And that's why it's actually easier to replace that y. And that's exactly the reason why in the second equation, in the linear equation, we're going to solve for y. That means we're adding x on both sides, which change it into y equals x plus 5. And in that case, we are going to replace the y in the other equation using the x plus 5, and that is the substitution step. So step 2, substitute the y in the other equation with the linear equation. So let's do that. Left side is going to become x plus 5 equals -x squared minus 3x plus 10. Now you see y is gone. We got an equation that's left with just x. So now we're going to solve for x either by factoring or quadratic formula. But no matter which method you use, you do need to move everything to the same side and leave the other side with a 0. So let's move the x squared, the -3x, and the 10. So we got x squared plus 4x minus 10 equals 0. And you just need to think, can you actually find a pair of numbers that can multiply to get a -5 and adds up to a 4? The answer is yes. So x plus 5 times x minus 1 equals 0, which means my x could be either -5 or 1. Last step, we're going to need to plug this x back into the linear equation so that we can find the corresponding y values. So, into here, when x equals -5, my y is -5 plus 5, which is a 0. So that pair of answer is -5, 0. The other one, when x equals 1, y is 1 plus 5, which is a 6. So that means my answer is going to be 1, 6. So these are both answers for the system. There you go. Moving on. Example 3. Let's go through the same process. So this one, x squared again, and 4x, which means it's easier to solve for the y. So to solve for y, we're actually going to move y to the other side. We'll add y on both sides and also add a 4 to move it to the left. We're going to get y equals 2x plus 4. And then we can actually replace that in the other equation, which will get us 2x plus 4 equals -2x squared minus 4x minus 1. Let's move everything to the left side to also make that 2x squared into positive. So we're going to get 2x squared plus 6x plus 5 equals 0. Now that means, well, it's time to start solving by factoring or quadratic. You need to find a pair number that multiply to get a 10 because it's 2 times 5 and adds up to a 6. There's no such combination. So that means we have to use the quadratic formula. Might as well check for discriminant. 6 squared minus 4 times 2 times 5, which is going to be -4. That means after you finish solving, the x would actually be complex numbers. So from here, you can already conclude no real solutions. That is our conclusion. If some question they do still ask you to keep solving, like it's asking you to find a pair of answers, even though they can't be graphed, well, we can still solve. It's just going to give us some complex answers. So x equals -b is -6 plus minus square root of -4 all over 2 times 2. So that is going to be -6 plus minus square root of -4 is a 2i all over 4, which is -3/2 plus minus 1/2 I. And we can still actually find the y values. So the y is going to be, well, when x equals -3/2 plus 1/2 I, the y is going to be 2 times -3/2 plus 1/2 I, and then plus 4, which is going to be -3 plus I plus 4, so it's 1 plus I. And if you actually check for the other one, x equals -3/2 minus 1/2 I, is very similar. Y is going to be a 1 minus I. So you can still write them, it's just it won't be real points on the graph, it would actually be in the complex plane. So the actual answer for example 3 is no real solutions. Moving on, example 4. This time, as you can see, same thing. The first equation, you already have the x squared and the x. So it's going to be easier to actually solve for y. So let's solve for y with the second one. Add 8x on both sides. So that's going to get rid of that. Then we can divide everything by a 4. Y is 2x minus 21 over 4. And then we can replace that into the first equation. 2x minus 21 over 4 minus x squared equals 7 minus 5x. So we can move everything to the right side so that the x squared will automatically become positive. So that's going to be x squared. So when you move that to the right side, move this, move that, it's going to be a subtracting 2x, so it's going to become minus 7x. And then add the 21 over 4 onto the 7, that's going to be a 49 over 4. And the other side is just a 0. You can choose to solve this with a quadratic formula just using the fractions, or you can get rid of the fractions by multiplying everything with a 4. And make sure you actually multiply every single thing. That's how we still keep the equation balanced. So that's going to be 4x squared minus 28x plus 49 equals 0. And that's where you may notice 4 is a perfect square, 49 is a perfect square. So you can check 2 times 7 is 14 times another 2 is 28. So you can use the formula or you can go through the factoring process. No matter what, it's going to get you 2x minus 7 times another 2x minus 7. That equals 0. So both parts will actually give you x equals 7/2. And then we can just plug back into the equation, the linear one, to find y. Y equals 2 times 7/2 minus 21 over 4. So it's a 7 minus 21 over 4, which is 7/4. Final answer, 7/2, comma, 7/4. That's example 4. Moving on, example 5. On this one, see, we have y squared and a y, so it wouldn't be easy to replace the y. In this case, it's actually easier to substitute the x. So I'm going to add y on both sides, and then divide both sides by a 3. That's going to get us x equals 1/3 y plus 2/3. Afterwards, we can actually replace the x in the other equation. That's going to get us 2y squared 2y² minus 6 times 1/3 y plus 2/3, and then minus 2y plus 6 equals 0. That's going to become 2y² minus 2y. Negative 6 times 2/3 is a minus 4, and minus another 2y plus 6 equals 0. Simplify everything. 2y² minus 4y plus 2 equals 0. In that case, I can actually divide everything by a 2. y² minus 2y plus 1 equals 0. That's actually a very easy equation to factor. That's going to get us y minus 1 times another y minus 1. That equals to 0. So y equals 1. Lastly, let's plug it back to find x. X equals 1/3 times 1 plus 2/3, which is a 1 as well. So final answer 1, comma 1. So as you can see, sometimes we can substitute the x, sometimes we can substitute the y. Depends on which one is going to make it easier. That's example 5. So example 6, you can pause here and actually try it out. The final answer for example 6 is going to be right here. So it's actually another question that's no real solution. There you go. Moving on. Last one, example 7. This is the one that looks a bit more complicated because you have x². Change the color. You have x², x. You also have y² and y, so it doesn't quite matter which one you substitute. Now it actually depends on the linear equation. To look at the linear equation, it's clearly easier to separate the x, so let's separate the x. That's going to be, so we can move the x to the right side and subtract the 3 to the left side. X equals 2y minus 3. Now let's start replacing everything into the first equation. Anywhere you see x, you are going to need to substitute it using the 2y minus 3. So it goes right here, and it goes to the front. So we got negative 4 times 2y minus 3 squared, and plus 6y² minus 27 times 2y minus 3, plus 6y minus 45, 45. That equals to 0. So now, it's time to simplify everything. I'm going to leave the first part at the end. Let's simplify everything else. We have 6y². Then we have minus 27 times 2 is 54y. And then we have the negative 27 times the negative 3 is a plus 81. And then still have the plus 6y minus 45. Still have the equal to 0. As for the first part, you have to be very clear. You do need to go with the square first and then multiply with the negative 4. Or you can choose to multiply the negative 4 with one of the 2y minus 3. And then whatever that is, multiply with another 2y minus 3. So again, you can either do it as 2y minus 3 times 2y minus 3. And then multiply the answer with the 4, with negative 4. Or you can choose to multiply the negative 4 into the first one and get a negative 8y plus 12, and then multiply it with a 2y minus 3. These are your two different options. Either way, the first part should give you, as you see, negative 16y² plus 48y, and that's going to be a minus 36. Okay, now let's simplify. Negative 16y² and the 6y², that's going to become negative 10y². We have the 48y minus 54 plus 6. Well, no y is left. And lastly, negative 6 and 81 and negative 45. No numbers left. So you see, even though the whole question seems complicated, if you follow the same procedure, well, eventually this is actually going to become very easy. Negative 10y squared equals 0, so y has to be 0. Now we can just find the x. X equals 2 times 0 minus 3, which is a negative 3. So final answer, negative 3, 0. There we go. That's example 7, and that is the last one for this lesson. Thank you.